Hi, 7th grade. I am going to introduce lesson 4-6, which is multiplying and dividing monomials. There are no vocab words, so in your notes you just need to start out with your heading, and then I am going to get right into the examples and explanations for you. So the first thing that we're going to talk about is multiplying monomials. Please remember that monomials are anything that has numbers and variables. It can have multiplication, it can have division, which means it can have exponents, but it cannot have addition or subtraction signs. So we have numbers, we have variables, we have exponents, and they're all being multiplied or divided. When you are multiplying two separate monomials, you can think of this as, let's see, a to the m times a to the n. So we have our base being the same, they're both a. Our exponent here is m, and our exponent here is n. What actually happens is you're going to keep the same base, that's not going to change. And you're actually going to take your two exponents and add them together. So you end up with the same base being taken to m plus n for your exponent. Let me show you what that looks like if we throw in some numbers. The most important thing for you to remember is that the base has to be the same for this to work. So here we have both of our bases are 2, and we have the exponent 3 here and 2 here. When you think about 2 taken to the third power, remember that you're multiplying whatever the base is, and you're doing that, we're multiplying 3 2's, and then here we're multiplying 2 2's, and you bring that multiplication down. So you can think of this in parentheses as this is your first number in exponential form, this is your second. But when you are doing all this multiplication, what you're really saying is that now you have 2's that you're multiplying, and now you have 5 of them. So this is a great way right here. If you forget this, this is a great way to remind yourself what you're supposed to be doing. So you might have same base, maybe 32, and you have 110, and then over here you have 32 to the 217th power. Well, we certainly don't want to have to multiply 32 that many times. So rather than that, we can use this trick and say, okay, well, it's 32 to the 110 plus 217, which would be 32 to the 327th power. That's what we're doing here. You're just adding the two exponents as long as your base is the same. If you forget that you're going to add the exponents here, I would really recommend just write this one out, because then you can see, oh, well, if I now have 5 of these, what would I do with my exponents? If I had 3 and 2 and I wanted to get 5, oh, I just add my exponents, that's right. And then you would know to just add your exponents. So here, our more simplified version is 2 to the 5th power. The next, oh, they give us another example here in your book. We have 7 cubed times 7. Please remember that if there is no exponent, how many 7's do I have? I have 1. So my exponent is really 1. When I take into consideration my rule here, I have the same base. They're both 7, so I can do this. My base is still 7. I'm going to add my two exponents. So I have 3 plus 1, and my answer here would be 7 to the 4th power. The next example, example 2, let me get this gone. Example 2 has, we have exponents, or I'm sorry, yeah, we have exponents on variables. So this time we have x to the 5th times x squared. Normally when you have a variable in your problem, there isn't much you can do to simplify. But in this case, even though we don't know what the base really is, we have x there. The base is the same. They're both x. So we are allowed to use this rule and say, all right, well, it's x to the 5 plus 2, which would be x to the 7th power. So this is a lot more simplified than that was. Even though we don't really know what x is, it could be anything, we have still simplified it. Oh, this is a good example. So example 2b says, in parentheses, we have -4, let's look up, -4 to the n cubed, and that's all in parentheses, times 2n to the 6th power. When you are combining these, we have exponents here and here. Both of those exponents are on the base of n. Remember that your exponent only belongs to whatever's directly to its left. So it's not the number, it's just the variable that's directly to the left. When you are multiplying things, we are allowed to multiply in whatever order we want. So we can, even though these parentheses are here, everything's being multiplied, so we can rearrange this expression, combine our numbers together. So we're going to multiply those, and then we have our variables taken to exponents, and we want to put those beside each other as well. Remember, when numbers are beside each other or beside numbers, they are automatically multiplied. If you want, you can put the dots in to show you're multiplying, but you don't have to. The next thing that we're going to do is now simplify. We're going to multiply our numbers. Remember, negative times a positive is negative. And then when I am multiplying these monomials with the same base, I'm going to add my two exponents. So 3 plus 6 is 9. And there is my simplified answer. -8 times n to the 9th power. When you are dividing monomials, so we're going to switch from multiplying monomials to dividing monomials. Keep in mind that in algebra, division is generally written as a fraction. So you're going to see things that look like fractions, act like fractions, but guess what? They're division problems. So when you are dividing monomials, so we have a to the mth power, that's weird to say, divided by a to the nth power, you are going to, as long as you have the same base, take that base to the whatever exponent is on the top number, your numerator. You take that exponent minus the exponent that's on your denominator, your bottom number. That's super important because a lot of people will try to take the bigger number minus the smaller number because that's what you typically do in subtraction. But remember that you guys know about negative numbers now, so it's not always going to be the bigger minus the smaller. This number could be smaller than this number, but you still have to put this one first. It's always your exponent that's on your numerator minus the exponent that's on your denominator. So let me show you a few examples of how this works. The first one I'm going to do is to show you how it works with a small number. so that you can do this again to remind yourselves that it's n minus n if you need to. So say I have 2 squared over 2 cubed. When you do this, you're going to take your base, your top number minus your smaller, top exponent minus the bottom exponent. And in this case, 2 minus 3 would be -1. Let me do another one. I'm going to switch my exponents actually. So say we do it this way. 2 cubed means I have 2 times 2 times 2. 2 squared means I have 2 times 2. When you're looking at these, remember from the last section, when you're looking at these, if you have the same thing on the top in your numerator and the bottom in your denominator, they cancel out. So we have a lot of 2's there that just canceled out. We are left with this 1, 2 on the top. So all we have left is the number 2. Think about what happens when we use our rule. So if we had this and we remembered, okay, we have the same base, I'm going to take my numerator's exponent minus my denominator's exponent, and that would be 3 minus 2 is 1. 2 to the first power, multiplying 2's, I have one of them. So my final answer there would be 2, same as I got here. And again, this right here is a great way to remind yourself what the rule is if you get stuck. Just use 2's and 3's, plug it in, see what happens, realize, okay, well, I should be getting up here, I should be getting the exponent 1 because I only have 1, 2 left. So how would I do that if my 2 exponents are 3 and 2? Well, it's 3 minus 2 equals 1. That gives me 1, 2. That gives me what I should have. So it helps you to remember what the rule is. When you look at a problem like this, so we have 5 to the 7th power over 5 to the 4th power. When you do this, if you remember the rule, you are going to have the same base, take your top exponent minus your bottom exponent, and you get 5 to the power of 3. Again, if you forget the rule, what you can do is expand this and say here, okay, I have 7 5's. 1, 2, 3, 4, 5, 6, 7. And then I have 4 5's. So I can cancel all those out, and look what I'm left with. 3 5's. Nothing on the bottom, which means my denominator would be 1, which means it goes away. So you can see I get the same answer both ways. Using the rule helps you to have a lot less work. So we like that when we can cut our work down. Next example has a variable as our base again. So we have this, y to the 5th power over y to the 3rd power. We have the same base, so we can use our rule, which is top exponent minus bottom exponent, and this would equal y to the 2nd power. Finally, in example 4, we have a lovely word problem with a table. It says the table compares the processing speeds of a specific type of computer in 1993 and in 1999. Sadly, I was in high school and college for those 2 years. Makes me feel old because you guys probably think that's like ancient times. Anyway, find how many times faster the computer was in 1999 than in 1993. So it shows us in the table that in 1999 the processing speed was 10 to the 9th power, and in 1993 the processing speed was 10 to the 8th power. So if we do this math using the rule, we can see that we get that, which is 10. So your answer here would be 10 times faster, which is pretty impressive. All right, so when you look down at check for understanding, I'm going to do a few more of these. I want you to keep in mind the two rules that we talked about, which the first one was, I'm going to use the same letters we did here, M and N. So if you're multiplying two monomials, you are going, as long as you have the same base, you're going to add your two exponents. If you are dividing two monomials with the same base, you are going to take the top exponent minus the bottom exponent. All right, so a couple more examples. Let's look at number 4 and number 5 first. So we have 9 cubed times 9 squared. If you check out the directions, it says find each product or quotient express using exponents. The express using exponents means all we have to do is use our rule. We don't then have to multiply all those 9s. So you guys will like that. All we're doing here is saying we have the same base. We're going to add our two exponents. So your final answer here is 9 to the 5th power. You do not then have to say, okay, well, what's 9 times 9 times 9 times 9 times 9? You don't need to do that. All you need to do is express your answer in exponential form, which is 9 to the 5th power. Number 5, we have this. I need you to remember there's no exponent there. It doesn't mean there's not an exponent. It means you need to think about how many a's do you have. Well, I only have 1, which means my exponent is 1. So when I have the same base, I add my exponents, I'm going to get a to the power of 6. Next one I would like to do for you is number 7. Number 7 adds some numbers in here. I think I've killed that marker. There we go. Number 7 adds some numbers. So what I need you to remember here is you are going to multiply your numbers, and then you are going to multiply your variables. So first thing we're going to do is take those two numbers and multiply them. So -3 times 4 would be -12. And then I have the same base on my variables with exponents, so I can add them. And this would be -12 times x to the 5th power. Oh, and that ran out of your screen. There we go. -12 x to the 5th power. Okay, now on to some division examples, which we're using this rule now, where you take the top exponent minus the bottom exponent and keep it on that same base. So number 8 is 3 to the 8th over 3 to the 5th. We have the same base. We're going to take the top exponent minus the bottom exponent, and we get 3 cubed. Well, let's look at number 11. So we have a to the 10th over a to the 6th. So let's have the same base. Take my top exponent minus my bottom exponent, and we get a to the 4th power. Something I want to warn you about that they will throw at you in these problems is, I keep saying you have to have the same base. You have to have the same base. You do, in fact, have to have the same base. So if they give you something like this, five cubed times 2 to the 7th power, we cannot use the rule on this. We cannot like decide, oh, let's multiply 5 times 2 and get 10 and then add our exponents. We can't do that here. This would actually just be simplified. If we are to give our answer in exponential form, this is as simple as we get. We can't use the rule here. Same thing with division. If you had, say, 7 to the 6th power over 2 to the 3rd power, we cannot use the rule here because we do not have the same base. So this, again, would be our final answer. You cannot simplify that further, keeping in the exponential form. When you do these then, the very first thing you need to check for is, do my bases have the same number or the same variable? If they do have the same variable or number as your base, then you can use these rules. If not, you're done already. You can't simplify it any further. So just write simplified. What I would like you guys to do next is on page 178. I want you to go ahead and try we're going to do 1539 by 3s. And this assignment would be due on Monday. So no classes for you guys tomorrow. Teachers have classes instead. So this assignment will not be due until Monday. But I want you to do page 178, 15 to 39 by 3s. As soon as you get it done, feel free to submit that on Rediker. And I did post a video explaining how to do that. So if you need help, you can check that out. If not, go ahead and submit the assignment on Rediker, and I will go over it for you guys on Monday. See you then. Have a great weekend.